So today we are taking page 85, electrolytic cells and electrolysis. So what do we know about electrolysis? What is electrolysis? So electrolysis means we use of external source of voltage. That means in simple words, we use electricity. And what do we use this electricity for? To bring about a chemical reaction. So for making this transformation with electricity, we are getting chemical energy. What are its requirements? So you can see in the diagram, we have our electrolytic tank. We have the electrolyte out here. In this example, I am showing you copper sulfate. We have it connected to a DC voltage, which is the electricity source. And we have the electrodes. In this case, both are nothing but copper plates dipped in copper sulfate. So to carry out the process of electrolysis, meaning to use electricity to bring about a chemical reaction, these are the requirements. So how does it work? So suppose we have taken this example, copper sulfate aqueous. So as soon as we put it in water, it will dissociate to give you Cu2 plus ions and SO4 2 minus ions. So what then happens at these two electrodes as soon as you put on your DC voltage or electricity? Cu2 plus aqueous means whatever Cu2 plus from copper sulfate has dissociated, that Cu2 plus aqueous will pick up 2 electrons and be converted to copper solid. So since we are adding 2 electrons, this is reduction. So we say that Cu2 plus is reduced at the cathode. And cathode, mind you, is the negative electrode. So Cu2 plus being positive will move towards the negative electrode. Then what happens at the anode? Anode is your positive electrode. So copper, which is solid, will go into the solution and get converted to Cu2 plus aqueous by giving out 2 electrons. This is the way it has been written in the textbook. Or you can visualize this, take the 2 electrons the other side, Cus gives out 2 electrons, leaves it at the anode, those 2 electrons, and goes down into the solution, into the aqueous solution as Cu2 plus. So we will say in this case, copper solid is being oxidized. So what is happening to this copper? You can see I have marked it with an asterisk to make you understand what is this Cu solid which is getting formed. This Cu solid is formed at the cathode, so the plate gets heavier. Already this was made out of copper, so now more and more of it is depositing, it is being formed. So in that case, this plate will become heavier. What about the other, this copper solid, which was this electrode? This is passing into the solution from anode, so the plate will slowly disappear. So it slowly disappears. So I hope you have understood what is electrolysis, what are the requirements for carrying out electrolysis, how does it work exactly when we have such type of an arrangement. Now the next question comes to our mind is, how much of this? We are saying that Cu solid is being formed at the cathode. So how much of Cus forms at the cathode? So this was found out by Faraday, and he has given his first law. So he has said that the amount, that means the mass of copper that is going to get deposited out there, will be proportional to the quantity of electricity. Q is always the symbol for, this is your electricity. And how do we calculate this? There in the textbook you will see this Q is nothing but I into T. What is this I? I is the current in amperes and T is the time in seconds. So if you multiply current into second, you get your quantity of electricity. So depending on how much of electricity you are passing into this solution, that much of copper is going to get deposited. This is the Faraday's first law of electrolysis. Then this is the quantitative aspect from number 4 I am doing. From 1 to 3 we are knowing the qualitative aspect. We are not thinking how much is getting formed, we are knowing only what is getting formed. So this is the qualitative aspect. And question number 4 gives you the quantitative aspect. Faraday's first law gives you quantity, how much of copper solid is getting formed. So by this we can understand the quantity of copper being formed. Now, suppose we have electrolytical cell being set up like this. We have 3 containers with 3 different types of solutions like this. So this is connected to the external source, and mind you, just see how I am drawing it. All these are connected in this way. So in the first tank I may have copper sulfate. Here in this tank I may have zinc sulfate, and in the last one suppose I have sodium chloride. Then what are the ions from here? Cu2 plus, Zn2 plus and Na plus. So just like your Cu2 plus gave you copper solid, so we can expect that CuS will get formed at the cathode out here. Similarly, zinc solid will be deposited at the cathode out here, and sodium solid is going to get deposited at the cathode out here. So we get 3 different types of solids from 3 different solutions if they are connected to the same electrical source. So Faraday's second law, this is your second law. The second law says, here also we can find out the quantity of copper, zinc and sodium. So the quantity, how much of this will, now if you are passing the same amount of electricity through all the 3, the amount of copper will be the equivalent weight of copper, the amount of zinc will be equivalent weight of zinc, and the amount of sodium will be the equivalent weight of sodium. So that much amount is going to get deposited at these electrodes. So here also we will know quantity. And how do we calculate equivalent weight? You will see in the textbook they have given to you. It is nothing but atomic weight divided by number of electrons. So why do we say that? Because you can see in this simple example we had Cu2 plus taking 2 electrons to become CuS. So we will take the atomic weight of copper and divide it by 2 because 2 electrons are being transferred. So we get the equivalent weight of copper. So for all these cases we will calculate in exactly the same way. Cu2 plus will require 2 electrons, Zn2 plus will require 2 electrons, but Na plus will require 1 electron. So atomic weight and equivalent weight is the same because it will be divided by 1. So this is Faraday's first law and Faraday's second law. Now the next thing that comes to our mind is these 2 electrons that we are saying is being transferred either here to get converted to this. So 1 electron carries 1 Faraday of electricity. So suppose it is 2 electrons, it will carry 2 Faradays. Suppose it is 3 electrons, it will carry 3 Faradays of electricity. Now what is this Faraday? 1 Faraday is equal to 96500 coulombs. So in this particular example, if they ask you how many coulombs of charge are required by Cu2 plus to get converted to CuS. So since it is 2, so you will write 2F or you will multiply 2 with 96500 coulombs. That will be the amount of electricity. If suppose Al3 plus requires 3 electrons to give you Al, then in that case you will say Al3 plus requires 3 Faradays of electricity to get converted to aluminium, or 3 into 96500 coulombs. So this is the way you will see in page, this is there in page 86, the last portion which I have asked you to mark as important. These type of questions they come. Calculate how many coulombs of charge are required by Al3 plus or Cu2 plus or Na plus. So just check how many electrons are being required to become neutral. So in that case, if it requires 1 into 96500 coulombs. If it is 2, then 2 into 96500 coulombs. If it is 3, then it will be 3 into 96500 coulombs. So that is the way we understand the electrolysis or electrolytic cell.